Alright, so this is geometry. The proofs review for the chapter 2 test. There's going to be 6 proofs that I'll be going over. The first proof, number 1, says that given we have measure angle 1 is equal to x plus 50, we also have the measure of angle 2 equal to 3x minus 10. And we're supposed to solve for x. Oops. If we look at the picture, we see we have angle 1, we have angle 2, and they are vertical angles. So I can say that angle 1 is equal to angle 2 because of the vertical congruent to angle 2 because of the vertical angles theorem, which says that if they're vertical angles, then the angles are congruent. And if they're congruent, then they're equal. So technically it's the measure. Measure of angle 1 is equal to the measure of angle 2. Definition of congruency, if they're congruent then they're equal, or definition of congruent angles. Alright, so now that I've established that 1 is equal to 2, I know that 1 is equal to x plus 50. I can substitute x plus 50 for 1, and I can substitute 3x minus 10 for the measure of angle 2. So I can say that x plus 50 is equal to 3x minus 10 because of substitution. And then I can subtract x from both sides, and I can say that 50 is equal to 2x minus 10, subtraction property of equality. Then I can say that 60 is equal to 2x using the addition property of equality. And then lastly, I can say that 30 is equal to x because of the division property of equality. So, given to me, x plus 50 is equal to angle measure 1, angle measure 2 is equal to 3x minus 10. It's given to me. I see from the picture that 1 is congruent to 2 because of vertical angles theorem. If they're congruent, then they're equal. Definition of congruency. Since angle 1 is equal to x plus 50, I'll substitute it here. Since angle 2 is equal to 3x minus 10, I'll put it here, and I can say x plus 50 equals 3x minus 10. Substitution. Then I can subtract x from both sides and say 50 is equal to 2x minus 10, subtraction property of equality. Then I can add 10 to both sides and say 60 is equal to 2x, addition property of equality. Then lastly, I can divide by 2 and say that x is equal to 30, division property of equality. And that's proof number 1. Proof number 2, it's given to me that y is the midpoint of xz So since I know y is the midpoint, that means that xz is cut completely in half, meaning that this guy over here, xy, is congruent to this guy over here. So I can say that xy is congruent to yz, and that is because of the definition of midpoint, which says that if it's the midpoint, then both sides are congruent. And if they're congruent, then they're equal. Xy is equal to yz. Definition of congruency or congruent angles. Now, next step, I have this bigger segment, xz, and it's made up of adding these two smaller segments, xy and xz, or yz. So I can say that xz is equal to xy plus yz. And that's due to the segment addition postulate, which says that the two smaller segments add up to make the bigger segment. Since I know that xy is equal to xyz, from here I can substitute yz right there, and I can say that xz is equal to xy plus xy. Why? Because of substitution. I substituted xy for yz. I can add those two guys together, combine like terms, and say that xz is equal to 2 times xy because of the distributive property, or you can say simplify, or you can even say combine like terms. I'll take them all. And so y is the midpoint of xz because it's given to me, and since y is the midpoint, I know that xy is congruent to yz due to the definition of midpoint. And if they're congruent, then they're equal. So xy is equal to yz. Definition of congruency. Because of the segment addition postulate, I can say that the bigger segment, xz, is made up by adding the two smaller segments, xy and yz. So xz is equal to xy plus yz. I know that xy is equal to yz, so I can substitute xy for yz, and I can say that xz is equal to xy plus xy. And then I can add them and combine them and say that xz is equal to 2 times xy because of distributive property, or because I combine like terms and I simplify. So that is proof number 2. Proof number 3. It states that the measure of angle 1 is equal to 10x minus 20. The measure of angle 2 equals 6x minus 40. That's given to us. I see that 1 and 2, they form a straight line, right? They're adjacent angles. I know that a straight line is 180, or I can say that they're supplementary, and these are examples of linear pairs. Angle 1 and angle 2 is a linear pair. Two angles that are adjacent that form a straight line, which is 180 degrees. So I can say that angle 1 and angle 2, angle 1 and angle 2 are supplementary. And they're supplementary because of the definition of linear pairs. Which says that if they're linear pairs, they form a straight line, which are supplementary. And if they're supplementary, then I know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That's due to the definition of supplementary angles. So I noticed that angle 1 is equal to 10x minus 20. I can substitute it here. Angle 2 is equal to 6x minus 40. I can substitute it here. And I can say that 10x minus 20 plus 6x minus 40 is equal to 180. Substitution property of equality. I can combine like terms. 6x and 10x is 16x, negative 20 and negative 40 is negative 60, and that equals 180. I can say that because of the distributive property, or I can say simplify, or I can say combine like terms. I'll take them all. I'm going to add 60 to both sides, and I have 16x is equal to 240. Addition property of equality. Then I can say that x is equal to 15. Division property of equality. So, measure of angle 1 is equal to 10x minus 20. Measure of angle 2 is equal to 6x minus 40 because it's given to us. Angle 1 and angle 2 are supplementary because they're linear pairs, definitional linear pairs. And if they're supplementary, that means that they add up to 180. Measure of angle 1 plus the measure of angle 2 equals 180 degrees, definition of supplementary angles. And then I substituted 10x minus 20 for angle 1 and 6x minus 40 for angle 2. And I can say that 10x minus 20 plus 6x minus 40 equals 180. Use substitution, property of equality. I can combine like terms and say 16x minus 60 is equal to 180. Distributive property of equality, or simplifying or combining like terms. Added 60 to both sides. 16x equals 240. Addition property of equality. And then lastly, I is divided by 16 on both sides to say that x is equal to 15. Division property of equality. And that is proof number 3. Proof number 4. Gives me these segments, and it tells me that segment AC is congruent to segment BD. Segment AC is congruent to segment BD, given to us. If they're congruent, then they're equal. Definition of congruency. I also have this little thing here that hasn't been defined yet, segment BC, and I want to say that it is defined. So I'm going to say that BC, this particular segment, is equal to itself. And I can say that because of the reflexive property, which says that any anything within a figure can be congruent to itself. So now we have defined these parameters. We have put BC into the proof because it wasn't set up before in any of the initial examples. So we had to put it in. Therefore, it is equal to itself. Next, I can say that AC is equal to AB plus BC. I can also say that BD is equal to CD plus BC. And the reason I can say that is because of the segment addition postulate, which says that the two smaller segments, in this case BC and AB, add up together to make the bigger segment AC. And the other segment, BD, is brought together by adding the segment CD and also BC. So look what I have. I have that AC is equal to this segment right here, AB plus BC, and I also have that BD is equal to this segment right here. So I can substitute those guys in. So AB plus BC is going to go in for AC, and CD and BC is going to go in for BD from line 2. So then I can say that AB AB plus BC is equal to CD plus BC. Notice that I have BC on both sides. That'll come into play in the next step, and this is because of substitution. Now that I have BC on both sides, I can subtract that out, and I can say that AB is equal to CD. Subtraction property of equality. Subtraction property of equality. If they are equal, then they are congruent. So I can say that AB is congruent to CD. Definition of congruent segments or congruency. So AC is congruent to BD because it's given to us. AC is equal to BD, definition of congruency. I have to define this BC because it hasn't been defined before. So I can say that BC is equal to BC due to the reflexive property. And I can say that AC is equal to AB plus BC and BD is equal to CD plus BC because of the segment addition postulate. It says that the two smaller guys add together to form the two bigger guys. And from line 2, since AC is equal to BD, I can say that AC is equal to BC, AB plus BC on the left hand side, and then CD plus equals, which is equal to CD plus BC on the right hand side because of substitution property. So AB plus BC is equal to CD plus BC. I can subtract BC out and say that AB is equal to CD, subtraction property of equality. And lastly, I can say that if they're equal, then they're congruent. Segment AB is congruent to segment CD. Definition of congruency. That was proof number 4. Okay, proof number 5. We are given that angle 1 and angle 2 are supplementary. We're also given that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And that's given to us. So if I look at 1 and 2 are supplementary, if they're supplementary, then it means that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And that is because of definition of supplementary angles. If they're supplementary, then they equal, well, they sum up to 180. If they're supplementary, they sum up to 180. So look what I have. I have that angle 1 and 3 equal to 180, angle 2 and 8 equal to 180. So I can get rid of the 180 and say, okay, since they both equal the same thing, then they can equal each other. And I can say that the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 1 because of the transitive property of equality. I'll also take substitution. So I have a measure of angle 1 on both sides, so I can subtract those guys out. I'm sorry, this is step 2. This is step 3. This is step 4. So I can subtract those eyes out, and I can say the measure of angle 2 is equal to the measure of angle 1. Subtraction property of equality. And if they're equal, then they are congruent. So the measure of angle 2, oops, I can't say measure. Angle 2 is congruent to angle 1. Oh, I'm sorry. Angle 3. Definition of congruency, or definition of congruent angles. Okay. 1 and 2 are supplementary. Angle 1 plus angle 3 equal to 180. They're given to us. If they're supplementary, angle 1 and 2, then I can say the measure of angle 1 plus the measure of angle 2 equals 180. Definition of supplementary angles. And if they both equal 180, 1 plus 3 and 1 plus 2 equals 180, then I can say they equal each other. The measure of angle 2 plus the measure of angle 1 equals the measure of angle 3 plus the measure of angle 1. Transitive property of equality or substitution. Since they both have angle 1 on both sides, I can subtract those guys out and say that the measure of angle 2 is equal to the measure of angle 3. Subtraction property of equality. And lastly, I can say that angle 2 is congruent to angle 3 because if they're equal, then they're congruent. Definition of congruency. And that is proof number 5. Proof number 6. And the last proof of this review of the proofs for the Chapter 2 test says we're given that angle 1 and angle 2 are complementary. We're also given that the measure of angle 1 is equal to 4x minus 26, and the measure of angle 2 is equal to 5x plus 17. All that's given to us. If we look at the first part, angle 1 and angle 2 are complementary, then I can say that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Because if they're complementary, they equal to 90 degrees. Definition of complementary angles. Definition of complementary angles. Notice that I have that 4x minus 26 is equal to angle 1, and 5x plus 17 is equal to angle 2. So I can say that 4x minus 26 plus 5x plus 17 is equal to 90. Substitution. Then I can combine like terms, and I can say that 9x minus 9 equals 90. You say distributive property, or I can say simplify, or I can say combine like terms. They all mean the same thing to me. I can add 9 to both sides, and I can say that 9x is equal to 99. Addition property of equality. And lastly, I can say that x is equal to 11. Division property of equality. So I can say that angle 1 and angle 2 are complementary. Measure of angle 1 is equal to 4x minus 26. The measure of angle 2 is equal to 5x plus 17 because it's given to me. Then I can substitute, then I can say that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Definition of complementary angles. Then I can substitute 4x minus 26 for angle 1 and 5x plus 17 for angle 2, and I can say that 4x minus 26 plus 5x plus 17 is equal to 90. Substitution. Then I can combine like terms and say 9x minus 9 equals 90. Distributive property, or simplifying or combining like terms. Then I can add 9 to both sides and say 9x is equal to 99. Addition property of equality. And lastly, I can say that x is equal to 11. Division. No, 9x equals 99, addition property of equality. And then I can say x equals 11. Division property of equality. Right, and that is our last proof for the Chapter 2 test review. I definitely hope you have a great rest of your day.